and yeah, for a meeting for questions about exercises or about the exam. Yeah, first I will share my screen. Now you should see my screen. Yeah. Yeah. First, I want to say something general about the exam for the module Particle Technology for IMP, so the internationals, and for the German course Particle Technologie 1-2. Yeah, but everything will be in English, so hopefully there's not a problem even for the German participants here. Yeah, after my monologue, you can ask me questions if you want. But I want to say that if you have questions, you can write or contact me, yeah, all the time, and I will answer as soon as possible, of course. Yeah, but hopefully, in general, for the organization or something, should hopefully no questions after this meeting. Okay. Yeah. The exam is on Thursday, the 3rd of March this year, of course, at 1 p.m. in Building H, Audimax 1. Yeah, please come early. Yeah, it would be great if you go to the toilet if you need before the exam start, because one thing I can say, yeah, at first year, the key for the exam is speed. You need every minute. The exam tasks are not very hard itself. But they are, yeah, it's much to write. So you need the time to write everything down. When you're quick, you can do this. But if you go to a toilet for 5 minutes in the exam, yeah, I wouldn't do this if I would write the exam, as a little hint. Yeah, overall, you have 19 minutes processing time for the exam. The total score is 100 points. And yeah, important thing is that we only give whole points. We don't give half points. So yeah, your answers must be correct. We cannot say, okay, yeah, half correct, so give a half point. No, we only give whole points. The whole exam consists of 4 tasks. These are 3 calculation tasks, which gives 75 points, so 75% of the exam are calculation tasks, and 1 question part, which gives 25 points. For the exam is only a non-programmable calculator allowed, and yeah, please bring your own paper. We will have some paper there only for someone who forgot to bring her or his own paper, but please keep in mind to bring your own paper. And yeah, please, yeah, you can bring a pad of paper, of course, but please remove single sheets out of it and use single sheets for your solutions. It's only to prevent you from cheating, to stick some non-allowed or not allowed little sheets of written paper in it or something. Yeah, please don't do that. And yeah, allowed is also a ruler, and please use a document-proof pen. So don't use a red pen, and please no pencil. Even for diagrams or something, don't use a pencil. Use a document-proof pen. Then we all are safe and we have no misunderstandings. Important thing is also the formulary. The formulary will be provided in the exam, so we give it to you with them. And it's the same you already had for the exercises. But the important thing is that do not bring your own formulary which you print out maybe at home or somewhere else. And yeah, don't make any notice or don't write on this formulary we give you. If you do this, we will interpret that's trial. Yeah, so don't do this. Only use it, like it is. Now, in general, for the calculation tasks, which is the biggest part of the exam, as I said, they are really, really strongly orientated towards the exercises. So this is a great hint from my side. When you can calculate all the exercises and the additional exercises in these, all the additional exercises in this collection of tasks, then you're really good prepared for the other tasks in the exam. Every topic from the exercise can be tested. I cannot say that this or this topic will be neglected. No, everything can happen and maybe will happen. Something a little bit stronger, something a little bit less, but you have to be prepared for every topic of the exercise. Yeah, a good orientation is that in the exercises there are old exam questions, and they offer you a good orientation for the type and the scale or scope of the questions. You can calculate around about 20 to 25 minutes for a calculation task, and for the question task only 15 minutes roundabout you will need to solve this. Important point, it happens every time, but I try it every time again. Do not forget units and axis labeling. Yeah, it's a really important thing. A value without a unit is worthless. Yeah, so, and it's a good control mechanism for you if this value can be true or not. Yeah, keep in mind the units and the axis labeling. A diagram without axis labeling is even worthless. If an explicit question is asked, like an exercise, maybe can the plant constructor guarantee mass flow in a silo? We want to have a short answer sentence or a short answer notice. Not only the calculated value, we want you to interpret this value only for short. Yes, he can. No, he can't. Something like that. It's okay. It's enough. You don't have to write down a complete book or something. No? Yeah, but this is important. You will have lost if you don't do this. Yeah, please write the solution on your own paper, and please take a new sheet for each task when it's possible. Yeah, you will not fail if you don't do that, but yeah, please do this. It's easier for us to check the exam later. There could be questions or tasks where part of the solution is on the exam sheet, but this will there directly. So when nothing is there, please solve it on your own paper. Yeah. A big point is additional formularies, maybe, because no one wants to learn additional formularies. And I can promise that all additional formulas which could be needed was in the exercise. Yeah, you don't need to learn some curious formulas out of the lecture or something. Yeah, concentrate on the exercises, and you have everything you need. There are some formulas or equations which are not in the formulary, as you know, when you visit the exercises. And yeah, I suggest to keep these formularies in mind, but every additional formulary or equation you need, which isn't in the formulary, we will provide. Yeah. Another big point is that your solution must be comprehensible. We have to know what you've done. But I say it directly, it is not necessary to write down every single step. For example, when you have equation and you convert it to another variable or something, it must be in general comprehensible, but to save time, don't show any step. Maybe when you solve an equation. Yeah, when you substitute an equation in another similar, makes it clearly visible that we know what you've done. When you calculate single values, like I don't know, for the stationary sinking velocity of a particle, please put the values in the final equation once time with units, and then type it in the calculator, and then write down the final value with units, and then everything is okay. When you need to calculate whole tables, then it would be too much time consuming to write every single thing with values down. When it's necessary, write down one time the final equation. Maybe if it's necessary with one example, but also this is not every time needed to do this. Or make it comprehensible, but when you make whole tables, write the solutions in the table, and if it's correct, you get points. If not, then not. Then we know that there's a mistake. Hopefully it's clear what you have to do or what it's not need to do. What I want to say, sorry. Okay, this was everything for the calculation part. I cannot give you any hints more than take a close look to the exercise, and then you will be safe for this. The second part is the first part in the exam, but the smaller part is the question part. This is 25 total score. The questions can be from all the topics of the lecture, unfortunately, including the separation of particles from fluids, but excluded are the fluidized bed technology and the conveying of solids, because this is the core of a higher lecture, particle technology 2. So I will not ask you about these topics in the exam, but I will be a little bit more precise in a few minutes. Where you have to take a closer look into, and what can be, I wouldn't say neglected, but it's not so important. You know what I mean. Which kind of questions will be there? Normal definitions or something, or sketches or drawings can be wanted. So you have to answer these questions with bullet points or short sentences. even know whole books or drawings, diagrams, something like that can be required. Yeah, general definitions, explanations of terms, graphs, schematics, like this can be asked. And yeah, please remember, keep in mind, access labeling is also there. Very often a big problem for some students. Yeah, keep this in mind. The solution for this task can be written down on the exam sheet. There is some space provided for that, and it's enough space for that. So for this task, you don't need your own paper, only for the calculation tasks. And now the interesting part, I would say. Now, yeah, I cannot write this down. I can only say it to you in an oral way because, yeah, no. What's next is only because I'm not an asshole. I want you that you don't need to learn everything. So I want to compromise your workload a little bit. So what I want to say for the question part is that you have a very good base if you take a closer look to the exercise as well. There was, before the calculation starts, a little theory part before, and these topics, which was inside this theory part, is really important. Yeah, really important. When you know this, you will, and you know, I will say everything, or you have a good knowledge about this, you have a great base also for the question part. Yeah, unfortunately, I have to take some questions out of the lecture to see who also read these lecture slides or visit the lecture. So yeah, if you only take a look into the exercises, you cannot earn every point out of the question part. Yeah. What is important out of the lecture? Out of the lecture is what can be neglected. I will start so. And this way, as I said, every calculation in the lecture, I don't know. I know there are some maybe example calculations. Yeah, when it wasn't in the exercise, it's not important for the calculation task, and it's not important for the question part as well. Yeah. What is important for me, because you have to know that I made the question part, so I know what I'm talking about. So what is important for me? I'll start in this way. Important for me are practical topics. Yeah, I don't want to know some curious things like curious formularies or something no one will remember after this exam or something. No, I am very concentrating on important practical topics such as basic mechanisms and designs of apparatuses. You don't need to know every type of a centrifuge or something. It's not necessary. There are 1,100 different types of centrifuges or silo designs or whatever. You don't need to know this. I will not ask this because every producer or make his own style and design of this. So why I should ask this? But I want that you know the basic mechanisms and the basic designs. So, for example, what are the basic mechanisms of particle separations or the forces on the particles during such a separation? yeah, gravity force, sedimentation is a fundamental mechanism, something like that. Yeah, such things you have to know, and you have to know that there may be, I don't know, a ball mill as an example of a mill, but you don't need to make a sketch of it. I can promise. You don't. You have to know the basic designs and yeah, the basic mechanisms. Also, every time important are forces. Forces are very important, I think. Forces on particles, for example, during comminution, separation or agglomeration. Also, the forces between particles you should know about. Yeah, how are how depend these forces or distance or something like that. Yeah, the fundamental forces and mechanisms. And it's very important to understand the basic interrelationships between the fundamental mechanisms and designs of apparatuses. For example, what do I mean? For example, how is a pressure course in a bulk material flow, and what is the logical design out of this course? Yeah, this could be a question, something like that. You don't need to know every graph out of the lecture. I know there are many of them. Same hint as before. Take a closer look to exercise. There are many of these important graphs included. Yeah, and it's really important to understand what the diagrams are saying. So what is the message of it? It's the same thing when you see a curve of a force, and I ask, okay, what is the message of this, and what can we say about design something which is compared to this diagram? Yeah, such questions can be asked. Yeah, dimensionless numbers are very popular. There are some dimensionless numbers we used, and you have to, or you should know, what is the meaning of these dimensionless numbers, and what do they put into relation, and where are they used, for what are they for. Yeah, in the lecture, once again, to the graphs, there are, in every topic, there are one or two important graphs, but if you take a closer look and you ask yourself, is this important? Or, yeah, keep in mind, I'm not an asshole. The last diagram of something I will not ask for, I will ask only for big important ones, yeah, if I ask. Also, a very important thing for me is, in a lecture are some cases or some possible problems of apparatuses. Yeah. So, and the solution of these problems or possible alternative processes. Yeah. This is very important for me to ask, maybe because in the real industry, maybe you will not be an expert for solid process engineering, but maybe for thermal process engineering or something. But maybe there is only one classifier or sieve in this process, and there's the problem with it, and maybe, I don't know, the sieve openings are blocked or something like that, and you have to know how you could solve this problem, what are possible solutions for it or alternative processes. Yeah, this is important for me, that you know how to solve such practical problems and what are the reasons for the problems. Maybe it's very important to understand this and the mechanisms behind it. Yeah, the derivation of formularies or something, yeah, only can be asked when it was in the exercise 2, and it was only one derivation of a formulary, and I think you know what I mean. I cannot say directly what it is, but it has something to do with a particle which is falling down. I think somewhere there. This is the only thing I know which could be. The last thing are important definitions. Can be asked, and I have to do something like that. Yeah, just stupid asking of this simple stuff, but you have to know some important definitions. And if you take a short look into the lecture and compare it to the exercise, then you will directly see, okay, what is important to know, what it's, yeah. Okay. And yeah, basic terms and classifications, like we have classifications after a very important and famous person in the topic of maybe separation or something, yeah. And not separation, classification. Yeah. I think you know what I mean. You should know this. Okay. This was it for the...
sorry, can you repeat the last thing you said?
The last thing is about the classifications. So the classifications, I mean, is, I don't know, if a number has a number of the value of 10, okay, what does it mean? Is it, yeah, I don't know. I cannot say it directly, yeah, I would be cheating, but remember the classification task or the classification part of the lecture and the exercise, and there was a really famous person who said, okay, when the value is somewhere between this and this value, then this process is a great process or normal process or not so good process, yeah, something like that. Yeah. This is such things. Maybe there are more than this, but these things could be also important. Yeah, this was it. I know it's maybe a little bit unprecise, but I hope I can give you, yeah, and imagine what kind of questions can be asked. And yeah, my hint is to take to think about, is it important for a practical thing? Yeah, when you see a crude theory of something, yeah, it's not necessary. Yeah. Okay. I want to say something about the bonus points out of the practical course, because there are always some questions about it. Again, they do contribute to passing the exam, so they do not help you to pass the exam. You have to pass the exam with your own points out of the exam, but if you pass the exam, these bonus points will be added to your points to change your exam grade to maybe a better one. Yeah. These bonus points do not expire if the exam is written later, or if you're not passing the exam the first attempt. They stay where they are. But when you write the exam, you pass the exam, and you accumulate after the past exam more of this bonus points, because you have to make some experiments again or something. These afterwards accumulated points cannot change your exam grade anymore. Yeah. Please remember the corona rules during the exam. I think you have to wear masks all the time. We have to wear masks all the time. Once again, a hint for me from my side is that speed is the key for the exam. The tasks itself are not so hard. And I will say I tried to solve the exam here. I have it right here in front of me. I tried it, it's finished, and it is possible to solve, yeah. If you have any questions about the exercise of the exam afterwards, yeah, now you can ask me here directly. You can write me a mail, or we can make an appointment for another Zoom meeting right before the exam to answer some questions, yeah. Then I have to say, yeah, good luck for the exam period. And now, yeah, as I said, you can ask me if you want something about the exam or the exercise. Yeah. Are there any questions?
Yes, actually, I have a few questions.
Directly a few. Okay, great.
Maybe I start with one. In the exercise 2.3.
2.3, yeah.
I had trouble even starting it, because I think the solutions didn't exist, or only the final solution, not the solution step.
Yeah.
So maybe if you could give me an idea how to start there.
Yeah, but at first I have to take a look in the question too. Okay, bike material is dry sieved on 2 products. Okay. Okay. Yeah, and your problem is how to start. Yeah. Okay. Yep. Yeah. In general, you have to calculate the separation function. You can calculate out of the density distributions of the course material and the feed material. Yeah. And you have given the cumulative particle size distributions, because out of the equations given for the feed material, you know that the cumulative size particle size distribution is 0 for particles which are smaller than 1 millimeter. You have formulary for particles between 1 and 10 millimeter, and for particles bigger than 10 millimeters, the cumulative size distribution is 1. So you can, you can put some values in it and calculate for the feed material, the course material, and the fine material, the cumulative size distribution. And out of the cumulative size distribution, you can calculate the density distributions. And when you have the density distributions, then you can put it into the formulary for the separation curve. This is the idea.
Okay, yeah, I will try to do that.
Yeah, maybe it's easier when you have a special problem. to make a photo of your solutions or your trial to solve this, send it to me via mail. Then I can take a closer look where your problem or your mistake or something is, and then I can answer much more precise. Yeah.
Okay. Yeah. Thank you.
Yeah. More questions? You said you had one more. Or you had several questions.
Yes. Also, with the Moore circle.
Yeah.
The exercise I couldn't solve with the information I found in the theory part, and also with your additional information you gave us. I didn't know how to solve it.
Okay. Yeah. I can say for the exam, this is not necessary. Yeah. So,
okay, great. Thank you.
So, yeah, because no, but for you're interested in what is going on there and how to solve this. It's difficult. This is the kind of question which is difficult to answer because, yeah, I don't have here a board or something where I can write on. What is your? You have to tell me what is your exact problem to solve it. So where is your exact problem? Because I cannot repeat everything about the Moore cycle. Yeah.
Yeah. Okay. I think we have 3 points given.
Yeah.
First the sigma x.
Mm-hmm.
And where do I draw the sigma x in the graph?
Yeah, the sigma axis is the x-axis. So the horizontal axis is the sigma axis, and the vertical axis is the shear stress axis. So every normal stress, sigma, is always directly on the horizontal axis. So when you make a diagram on the x-axis, you have to mark these 2 points.
So I, for instance, I go 5.2 centimeters to the right and 2.25 centimeters down.
No, not down. It's
and 6.5 centimeters up.
Yeah, right. You have to go. So your first point would be maybe 5.2 centimeters to the right, to the positive.
Yeah.
And you have a shear stress of 65 kilopascal. So you have to go 6.5 centimeters downwards. It's the first point, or upwards. It's completely.
Okay, it's arbitrary.
Mm-hmm. Okay. And then there's your first point. At your second point, on the x-axis, you have to go minus 2.2 centimeters, also 2.2 centimeters to the left, and 6.5 centimeters to the top or bottom, and there are your that is your second point.
Okay.
And when you combine it with linear, when you combine a linear, the point where this line meets the x-axis, there is your middle point of the Moore cycle, Moore circle.
Okay. Yeah. Yeah. May make sense to me.
Yeah.
Good. Yeah. Thank you.
Mr. Bump?
Yeah.
We wouldn't be expected to draw like the Moore circle diagram, right? Like it would we?
Oh, say, no, you don't need to draw this.
Okay. For the diagrams, like I remember in some of the exercises, like the figure was given to us already, and then we would just use like the figure to maybe like read some values off of it.
Mm-hmm.
If it's given in the exam, can we just use it directly off of the exam sheet instead of like trying to make our own diagram?
I don't know what kind of task you exactly mean.
Like I guess an example would be like if we were trying to get like the bulk density.
Mm-hmm.
I think you used a diagram in the exercise.
Mm-hmm.
Would you also, if that type of a question was asked in the exam, would you also provide the diagram, or would we have to create it ourselves?
In the exam, everything is clear, what is given and how. It could be possible, of course, that we have a diagram and you have to read out values of it out of it. Can happen, or we have something like an equation for it for the bulk density or something. Mm-hmm. There will be a formulary where you put your given values in, and then you can calculate what you want. Yeah.
Thank you.
Yeah. No problem. Yeah, I take a close look on the exam, and everything is completely given what you need with the units you need. I think it's very clear what you have to do and how you can get the values you need. But yeah, on one or two points you have to think about how you can get the values here, of course, because it is an exam. But as I said, if you are well prepared with the exercise, it should be no problem for you. Some other questions? And here a question in the chat. How would little calculation and round of errors be marked? So you mean how is the tolerance we give for such values we want to know, or what is the question? Okay, yeah. It depends on the task, because we know when you have to draw something and or read out of a diagram, there's a big tolerance, yeah, because yeah, you have to be fast and the diagrams are not so precise, so we do not expect a very precise answer, so your answer don't need to be exactly the same as ours. But if it's completely off, I remember last year there was a person, his or her mark was right between 20 and 30 and a little bit more to 30, but the answer was 22, and this can obviously not be the case. Yeah, we are very tolerant with such solutions, but yeah, then not. Yeah, it has to be in the range roundabout. When we have pure calculations, I think yeah, we will see when your calculation is correct, and when you round a little bit to the, I think the third the third place after the comma, after the point, yeah, everything will be okay, even if it's you calculate 2.35 and our solution is a 2.31 or something, it's also correct. Yeah, when we see your way is correct, everything's okay.
And if we calculate the first value wrong, and then we use this value for the next solutions, how will that be?
Yeah, you will earn following points. So if you failed to make the first calculation correct and yeah, you need this value to solve the other tasks or the other subtasks, and you make it wrong, but you make everything further correctly with this wrong value, you will get all other points, excluding points for the wrong first value.
And if we don't know how to calculate the first value and we just assume a value, is that also possible?
Yeah, for critical or at critical points, I think we will give some hints. So there will is a hint, or there will be a hint. Yeah, if you cannot calculate this value, assume this value. I will decide. Oh, it's okay when you say okay, I can not solve this and assume this when you write it down. It's okay. It's the same thing. You will get the following points.
And if we have a formula and we decide to solve it completely with our calculator, do we have to say, okay, we solve this with the calculator, or can we just
you don't? Yeah, I know what you mean. Maybe for something like what's the name for here? Yeah, I know what you mean. When you have an equation and the variable is somewhere in the equation, but not at the beginning, yeah. Not on the left side, of course you can take the calculator, but then it has to be correct. Yeah. But wait a second. I suggest to convert it to the final value when it's easy to do it. I suggest to do it so. It could be that 1 point is given for the right final equation.
Okay, yeah, that's a good information.
Yeah. And there's another question here in the chat. When you say whole points only, do you mean that we can either get all points or 0 points for a sub-question? Sorry, I don't understand this question. You can only own or earn whole points. So when task gives 5 points, so for every step, I don't know, you have to make 5 core steps in this task. You make little mistake in the first, as asked from Mr. Eugen here. Then the first whole point you will not earn, but the other 4, when it's correct with your wrong first value or your wrong calculation, you will earn the other 4 points full, completely. It's not the case that if we ask in task, I don't know, task 3A for something, and it will give 5 points, and you make there one little mistake that you have no points there out of the 5. No, it depends, yeah, on the core steps in this task. Yeah, this is what I mean. But we cannot say, okay, we give here half point, there a half point. For the calculation task, it's not so a problem. Yeah, it can be right or wrong. The problem can be the question part. This is what I mean. This is the main problem where sometimes a half point could be suitable because it's not really wrong, but also it's not really correct, because last year I asked what are the fundamental mechanisms or methods to separate particles from fluid. And yeah, I didn't expect that so many will write to evaporate the liquid or the fluid. I thought, okay, it's clear that we are in mechanical process engineering, so I want to know the mechanical processes. But so many give this answer, but I don't want this answer because I want to hear what we have here in this lecture. This would be a point where, okay, it's not really wrong, but it's not what I expected to hear. There, of course, wouldn't would be suitable to give a half point because yeah, it's not false, but was not part of this lecture. Yeah, this is what I mean, or this is the main point why we don't give. Well, this is the important thing why we give only whole points. Why this information is important. Okay. Some more questions?
I have more questions, but I think it would be easiest if I take a photo and send it to you.
Yeah, it's much better. Yeah. Then, as I said, if you have any questions, please write me a mail and I will answer as soon as possible. And yeah. Okay, here's one more question. So any paper type is allowed? Yeah, you can use clear paper, you can use with lines. Yeah, please don't write on a colored paper or something. I would be curious. Simple white paper in all forms is completely okay. There are no restrictions. Yeah. Yeah, then have luck. And yeah, we will see in 2 weeks, I think. Yeah. Then, bye.
Thank you. Bye.